Alright guys, so today we're going to look at Chapter 4, or Module 4, and basically supporting power supplies and doing some troubleshooting. That's going to be the subject for this week's labs and also for this week's assignments. Let's go ahead and get started, and we'll move forward and look through these slides. Alright, so here we are, Chapter 4. And the objectives for this module describe methods and devices for keeping a system cool. Heat is the enemy of all electronics, and so basically the cooler you can keep your system running, the better it's going to run and the longer it will last. Power supplies, you need to be able to calculate how much power, how many watts of power you're going to need, and then find a power supply that will provide that amount of power. Demonstrate organized approach to solving computer problems. There are steps to follow, and if you follow the steps, you'll get to the right place. Troubleshooting problems with an electrical system and troubleshooting problems with motherboard, processor, and RAM. We've already looked at some of these, and we're just going to continue on and look at some more of them. Cooling methods. If a processor, motherboard, memory, expansion, any of those components overheat, the system can become unstable, stop functioning. In fact, they're designed to stop functioning. They're designed to shut down when it gets too hot, or the components can be damaged. And when that happens, then you end up having to pay to replace them. So extra heat is not good. Devices used to cool a system: CPU and case fans, coolers, which are a combination of fan and heatsink, the heatsink by itself, and then liquid cool systems. Those are some of the more popular, more common ways to cool a system. Keeping cool inside the case, general rules: number 1, keep the case closed. Number 2, keep the dust bunnies cleaned out. And number 3, move it to a place where there is not there's not a bunch of dust or carpet. If your computer is sitting on carpet, you need to move it off the carpet. You need to get it up off of the floor and up maybe into a desk or somewhere where there is a little more controlled environment where you don't have so much dust, because dust equals heat and heat equals kill your computer. Processor fans, coolers, and heat sinks. Systems use a cooling assembly designed for specific processors. That means that different processors require different kinds of coolers. However, what's common among all coolers is that it's going to keep the temperature of the processor between 90 and 110 degrees Fahrenheit. Now that's still very hot. So safety rule: if you're working inside a computer that's been recently running, do not touch the processor, do not touch the heatsink, because they will burn you. They are very hot. This is just about hot enough to boil water. So you don't want to do that. Well, halfway hot enough to boil water. Still hot enough to burn your skin. Don't touch the processor. Coolers sit on top of the processor. Essentially, it's a large block of aluminum with a fan sitting on top of that. That's the heat sink, is the block of aluminum, and the fan is what it is. Heat sinks, basically it's a block of aluminum with fins carved into it, and the fins actually draw the heat away from the processor, and then the fan blows air between the fins to cool the fins and dissipate the heat. Usually made of aluminum or copper, or a combination of both. Copper ones are very expensive, but they are more effective. It's tied to the motherboard using wire, plastic clips, and between the processor and the bottom of the heatsink, you'll find a kind of a silvery looking, looks like almost like a powder, but it's actually a paste, and it's called thermal paste or a thermal compound. And basically what it does, it facilitates the transfer of heat between the processor and the cooler. The fan gets power from a 4-pin fan header on the motherboard, and usually it'll have a wire that plugs in there. So if we're looking at the basic assembly here, this part that is aluminum, the part down here is the heatsink. It's just a block of aluminum with fins or vanes, and then this flat surface here is what sits on top of the processor. And then this wire, you'll notice it has a 4-socket plug on the end of it. That's what plugs into the motherboard to provide power for the fan. The fan is inside here. It blows air through these vanes, and that dissipates the heat. There's a close-up picture of, this is a 3-pin CPU. Basically what that means is it doesn't have a thermostat. A lot of the newer fans will actually have a thermostat that tells your fan when to run and when not to run. And the reason why is it cuts down on the noise, because any kind of fan is going to generate a little bit of noise. And so if you've got a thermostat that runs your fan, it will shut down sometime when the CPU is not too hot, or when it doesn't need to be running, the fan will stop, and that cuts down noise. This is on the motherboard. This is the 4-pin. One of these pins is a thermostat. So basically what happens is if you got a 4-pin, it will send information to the fan whether to run or not to run. By the way, a 3-pin power cord will work with a 4-pin setup. You just have to figure out which one of these pins, usually it's going to be the extreme right or extreme left, which one of those is not a power pin, and plug it in with the 3 that are. So yes, you can use a 3-pin fan with a 4-pin power. You just need to know which pins are which. To prevent overheating, you can also add additional case fans. This is particularly important if you have a large graphics card. If you have a newer model graphics card, high performance, they generate a lot of heat on their own because they have their own GPU. And so you can install additional fans that blow on those cards, and that will keep the case a lot cooler. Case fans move air around inside the case and help force it out the vent so it takes the heat with it. Most cases have one or more positions in the case that'll hold a fan, and also you can find fans that are PCI slot compatible. That means basically it's a PCI card that has fans on it, and these you would put down in your slots next to a graphics card so the fans will blow directly on the graphics card. Also, RAM coolers. Basically, it's a cover that goes over the RAM chips, and then there's a heat sink connected to that, and then probably a fan that keeps your RAM chips cool. This is what a GPU cooler looks like. Notice there's 2 fans on it. It has a PCIe slot that it will fit into, and it sits in the back just like a card does, only these fans blow onto the graphics card. So you'd put this next to the graphics card in the order of slots, and these fans will keep the graphics card cool. Same thing here. This is the cover that goes over a RAM chip, and this is a copper heatsink and a fan, and then there's a 4-pin Molex connector. Basically, this is the kind of connector that an IDE hard drive would use if you think in those 4 pins. But you can connect this to your power supply, and this fan will get power, and it'll keep your RAM modules cooler. You can also get a liquid cooling system like a car. It has a radiator. It has a pump that pumps liquid around inside the case. The liquid flows through heat sinks that are covering the chipset on the board, and basically then the liquid flows out to the outside or the back part of the board where a fan blows over vanes similar to what's in the back of your refrigerator, and that fan blowing over those vanes with the liquid flowing through it will generate or will dissipate a lot of heat. Usually this is used by someone that's overclocking an AMD chip. Let's say you buy a 3.2 gigahertz AMD chip and you want to run it at 4.4, 4.1, somewhere around there. It's going to get very, very hot and it will burn up. So you want to put a liquid system in there to keep it cool. This is what this liquid system looks like. You'll notice these black tubes here. Essentially what they are is they are radiator tubes. The liquid flows through there. It flows into these vanes over here on the back next to the grill, and these fans push air over the vanes, which cools the liquid, and it flows back into the processor, and the cooling process starts over again. Okay, let's look at power supplies. Essentially, a power supply is, number one, an inverter to convert from AC to DC power, because all computer components are DC powered. And number two, it's a step-down transformer. So the power coming in from the wall is 110 volts of AC, and nothing in your computer will use that. So you have to change that to 24 or 12 or 8 or 3.3 volts. And basically your transformer inside your power supply does that. So there are two reasons to replace the power supply. Number one, if it fails, which happens. Number two, if you're upgrading your computer and adding more components like a more modern video card, a lot of times you're going to need more watts than the original power supply will provide, and so you would add a bigger power supply with more plugs. You can purchase a computer case with the power supply already installed. This is probably the best way. Or you can purchase a power supply separately, but you need to make sure about the form factor. Will this supply fit this case smoothly? Does it fill up all the holes? Does it leave any space for dust and air to get through? Things like that. Important considerations, once again, form factor. The case and the power supply need to fit each other. Wattage rating, you need to be able to add all the components together, all the power requirements for your GPU, your CPU, all the other things like that. You need to be able to add those things together and get a total power requirement, and then check your watts for your power supply and make sure that the watts in the power supply are greater than the watts required. Number and type of connectors, particularly if you've got a newer system, you want to add newer components, you need to make sure that your power supply has the newer power connectors. It needs to have a fan inside it because power supplies generate a lot of heat because the step-down transformer, that extra energy has to go somewhere and it generally transforms into heat. And so you need a fan to cool that off. Dual voltage option, if you look at most power supplies, they have a little orange switch right below the cutoff power switch. There's a small inset orange slider switch that'll say 115 or 240, and basically what that does, that allows you to use a 240 volt system in Europe or a 115 volt system in America. And then warranty, finally. Warranty is important. Anytime you buy a computer component, get something that's made from a large manufacturer. Buy something that has a good warranty, because as far as the quality goes, for the most part, those components are all the same. They're all made in Malaysia. They're all made from the same parts. What's important is if it breaks a week after I install it, can I get it replaced for free? So you want a good warranty. Okay, so we're looking at a power supply here. This is a 525 watt power supply. So what you're going to do is you're going to look at your video card, your processor, all the components inside your computer. You're going to see how many watts each one required. Usually you can do that by looking at the motherboard documentation, the processor documentation, the graphics card documentation, and what you'll be able to do then is determine if that total for all those requirements is equal to or less than the amount of power, 525 watts, that the power supply will provide. If not, then you need to go up, get a bigger power supply. Okay, just to give you some examples for types and characteristics, SATA hard drive. This is the power supplied to a hard drive, either a solid state drive or a SATA hard drive, using the 5-pin flat power connections. 3.3 volts. It takes a plus 3.3, plus 5, and plus 12. So it requires 3 different powers. A Molex power supply. This is for older IDE drives, and also if you happen to have a floppy drive for whatever reason, or not a flop, pardon me, a CD-ROM drive or a DVD-ROM, it requires a Molex. Those are the 4-pin power plugs that the older drives require. It requires plus 5 volts and plus 12 volts, and then a 24-pin P1. This is a newer main power connector. This is the 24-pin. Actually, it's 20 pins plus 4 pins is how you would look at that. This is for the power to all the parts of the motherboard, and it requires plus 3.3 volts, plus and minus 5 volts, and plus and minus 12 volts. So there are different positive and negative requirements, as well as different number of volt requirements. Polarity, that's what I'm looking for. There are different polarities required by the different components as well, because some things take a negative 12 volts, some things take a negative 5 volts. So you need to make sure that your power supply will provide all these different voltages. And how to calculate wattage capacity: consider all the components in the case, consider the USB devices that you're going to use, look at the documentation to get the power requirements from ports connected to the motherboard, and then add them up. Now, power supply should be rated 30% higher than what is expected need. So if you've got a requirement for 150, then you're going to have to add an extra 45 watts to that, because 30% of 150 is 45. So you'll add an extra 45 watts. That means you would have a minimum of 195 watts that you would need. So you add them up, you add the 30% in, and then you can go shopping for your power supply there. If you're going to add things up, motherboard, processor, this is the general motherboard requirements here. And that's usually 200 to 300 watts for this particular imaginary system that we're building. Fan, you're going to need 5 watts for that. SATA hard drive, remember we talked about that, 15 to 20 to 30 watts. DVD drive, 20 to 30 watts. If you got a PCI video card, which that would be a really old video card, but 50 watts. Any other PCI card, like a network card, sound card, anything like that, it's 20 watts. If you've got a PCIe video card, this is going to be a more like a gaming video card, and you're going to have 150 to 300 watts. And then any other PCIe card is going to be at least 100 watts. So you'll add that up, 305, 335, 365, 415, 425, 725, 825. So you've got 825 watts required. Then you need to get 35% of 835, which is going to be about 200 watts, roughly, give or take. And remember, this is give or take. Now, you want to be more precise than I'm being. So you're going to need at least 1,000 watt because you're needing 800 plus 35%. So you're going to at least need a 1,000 watt power supply. You want to add that 35% because you want to give your power supply plenty of overhead, because the requirements for these components are not locked in. So you always want to go bigger than what you need. Strategies. Let's go to looking at troubleshooting. There are some things here. You want to look at these. You want to look at these slides because you want to be able to get very familiar with this particular flow diagram. So when you start, you want to question the user, and while that's happening, you want to get the user to back up their data. You absolutely want them, if they can boot their system at all, they need to back up everything that's on it that's important. Number 2, you're going to establish a theory. So number 1, interview the user. You're going to talk to the user and then back up data. Number 2, establish a theory. You're examining the system. You're asking questions still from the user. You're still interviewing. And then you make a best guess. What could the problem be? Then test your theory. Do whatever you can do to test your theory. For example, if your computer is completely black, it sounds like it's booting up, the fan turns on, but the screen is black, it's possible that someone might have adjusted the refresh rate for the monitor to be too high and the video card won't support it. So the way that you would test that is you boot the system up. Number 1, see if it'll boot up in safe mode. You start the computer and tap the F8 key until it gives you the option to boot up in safe mode. And at that point, you can look at the video settings and see if the refresh rate's too high for the monitor. If that's the case, if your guess is confirmed, then you can go do what you need to do to fix it. If that's not the case, you can give up. No. You can escalate it up to someone else who maybe understands a little more than you do, and then that would be a stopping point. Actually, what you should do, though, before you just give up is go back and establish another theory. And you can go back and establish theories till the cows come home. Don't just give up. That's I don't know why they even put that in there like that. Okay, once you have established that your theory is correct, then you plan the steps to fix the problem. Okay, what do I need to do? Well, the first thing I need to do is adjust the refresh rate. I need to boot up in safe mode, adjust the refresh rate, save it, reboot, and let it boot up in normal mode and see if that fixes it. So you do the steps, fix the problem, and then verify that it worked. Now when I boot it back up, am I able to look at my monitor? Hey, I am. Problem solved. Yay, team. If not, then I got to go back and establish a new theory because something didn't work. Keep establishing theory, keep testing it, keep applying the steps until you get it to work. And when it works, then there's some more stuff to do. Number 1, you want to document your finding. And that's going to be a thing you want to do constantly. Document what you did. Document your steps that you followed, because you can establish a knowledge base at that point. This is particularly important if you're working at a company. If you're working for a company and you've got people coming and going on the IT team, you want to capture all the knowledge you can capture, because when you do that, then the people coming after you have the benefit of your knowledge. So you ask yourself, could this problem have been prevented? Well, how could we do that? Well, don't let people adjust the refresh rate. So take preventative action. Do whatever you can do to prevent that from happening, and then document what you did. Document the steps you used to solve it. document the steps you use to take preventative action, and at that point then you can consider this to be complete. However, it's a good idea to check back and verify. Maybe next week you go talk to that person that you're working on their computer, you see them at lunch and you say, hey, the monitor's still working, everything's still good. You always want to verify, because that's number one, it's good customer service, and number two, it allows you to catch things that maybe you didn't catch the first time. So, steps: interview the user, back up data, examine the system, analyze the problem, and make an initial determination to establish theory. Test your theory. After you know the source of the problem, fix the problem, plan the steps, and then work the plan. Verify the problem is fixed and that everything works. Document everything, and then to add one to this, go back and check. Go back and verify later, hey, did this work? Resources that you can use for troubleshooting. Of course, the internet is the biggest one. Chat groups, forums, email, technology support. That's all internet. Manufacturer's diagnostic software, if it's available. Maybe, maybe not. It depends on if you are a manufacturer's rep or not. If you're a manufacturer's preferred technician, like if you work for Dell specifically, or you work for Compaq, or you work for Acer or whatever, then you'll have access to diagnostic software. If not, then you probably won't. User manuals, same thing. If you're a manufacturer preferred technician, you'll have access to the manuals. Technical associates in your organization, there's always somebody that has an answer. Ask people. 13 rules found throughout the next section. And rule number 1 is approach the problem systematically. Follow the steps that we looked at up here. You follow these steps and continue to work the plan, you will solve the problem eventually. It just works that way. You'll go through the steps enough times, you'll finally solve the problem. Okay, now how to interview the user. This is the person whose computer has the problem. So ask them questions like these. Can you describe the problem? Error messages, unusual displays, what's going on, what actually happened? When did the problem start? Did it start this morning? Has it been going on for weeks? What was the situation when the problem occurred? Did you just boot up an incredibly resource-intensive video game and suddenly your computer slowed down? Is that what it was? All these things can answer your questions, or the answer to these questions can help your troubleshooting process. Have you added any software? Did you add one of those freeware virus checkers from the internet, and now your computer's suddenly running very slowly and you're getting lots of pop-up ads? Changes to the system. Have you added any hardware? That's a big one. Hardware, software configuration changes. Has someone else used your computer lately? Is there valuable data on your system that is not backed up? Are the entire company financial records on this system? Probably it's a good time to back them up. And finally, the most important, can you show me how to reproduce the problem? Because if you do it and it's a problem, and I do it and it's a problem, then it really is a problem. As you talk with the user, keep in mind rules 2, 3, and 4. Establish your priorities. What is the main issue here? Beware of user error. Sometimes it's not a hardware problem at all. Sometimes the users, well, spent the last 5 years turning my computer off by unplugging it from the wall instead of using the power button and doing the proper shutdown. Keep your cool and don't rush. Don't get in a hurry. There's no reason to hurry. After talking to the user, make sure you back up any data that's not currently backed up before you ever begin to work on the computer. Use File Explorer to move it onto a USB hard drive, onto an external drive, onto a network share. If you have to, and it's a hard drive problem, then you may have to get a professional file recovery service, which those are expensive, but they can save your life. Rule 5 and 6, make no assumptions. Make no assumptions about the system and make no assumptions about the user. Take them at their word. Rule 6, try the simple things first. That's the best way. Like I said a while ago, if you've got a monitor that won't light up, that's you can't see anything on it, don't immediately assume that the monitor's completely burned out. Assume that, hey, maybe somebody didn't plug it in right. Maybe the cords are loose. That's not the case, then maybe they set the refresh rate wrong. That happens so often. People go in there, oh yeah, I want my refresh rate to be 120 cycles per second. However, you got an old CRT monitor that at best it's going to ever do is 60. You set it for 120, your monitor's going to go black and it's not going to come back on until you change that. Make your best guess as the source of the problem, and don't forget to question the obvious. Become a researcher. Get online. Go to the forums. Go to the manufacturer's websites. Become a researcher. As you test your theory, rules 8 through 11 apply. Divide and conquer. Break the problems down into little steps and solve the little steps, and eventually you'll have all of them solved. Write things down. Write down what you tried. Write down what worked. Write down what didn't work. This will help you in your documentation later. Don't assume the worst. Like I said, it may just be not plugged in. Reboot and start over. Fix something, reboot, start over. Reboot, start over. You want to do that a lot. Okay, this is just another flow chart basically to help you walk through the steps. This is a flow chart that will be on the CompTIA exam. So it's a good idea to become familiar with it. In fact, that's why I gave you these. You have access to these slides. It wouldn't be a bad idea to maybe pilfer this flow chart, screen capture it or whatever, and then put it on your desktop so you can see it. What does a blue screen of death look like? Well, it looks like that. This is an old blue screen of death, by the way. Nowadays they don't look quite like this, but they're still blue, and they still basically provide a lot of information that you can do, that you can look up on the Microsoft website to find out why Windows would give you a screen like this. Look at the post documentation. Learn how to pull up information in the command prompt. You need to be able to use command line tools. You need to be able to pull up stuff. You need to be able to look at the event viewer. You need to know what that is and where it's at. And you need to be able to look at a post error message. This happens when the computer's booting up. So DMI pool data, that worked, but then a disk read error occurred. Generally what that means is you've got a bad hard drive or bad sectors. So you need to know when this happens. Beeps. So we're going to look at beeps. So one short beep or no beeps during post, hey, that means it works. In fact, most computers nowadays don't beep at all during post if it worked. One long and two shorts. That, for if you happen to have an award BIOS, that means you got a video problem. No video card or bad video GPU or memory. Same with Intel BIOS. If you got an Intel BIOS, that means you got a video problem. Continuous short beeps. You got bad memory. You got bad RAM if it's an award BIOS. If it's Intel, you've got a loose memory or a loose card or a board short. One long, one short. If it's an Intel BIOS, then you got a motherboard problem. If you hear beep, beep, then start pulling the motherboard. One long, three shorts. If that's an Intel BIOS, you got a video problem here. Three long beeps. If that's Intel, then the keyboard, your keyboard's not plugged in. Continuous, two short beeps and then a pause. That can also be a video card problem in an Intel BIOS. Three short beeps and a pause means your RAM chips are bad, or they're not plugged in properly. 8 beeps followed by system shutdown. That means the system has overheated and you need to clean out your dust bunnies. And then if you have continuous high and low beeps, dee-doo, that means you have a CPU problem and you really do have a problem. So it's a good idea at that point. You're going to probably be doing some extensive upgrading. Planning the solution. Rules 12 and 13. Use the least invasive solution first. Don't format the drive right off the bat for every single problem. Fix things first before you just apply nuclear waste or nuclear blast to the thing and just like format C:, all done. Know your starting point. Know where you began at and don't make things worse. Do the following to plan your solution. Consider different solutions and select the least invasive one first, and then work your way up the invasive scale. Least invasive to next least, and so on. Before applying the solution, do your best to determine what works. Test thoroughly, and then fix the problem. After fixing, reboot. Regardless of whether you need to or not, reboot the system and verify that it boots up. verify that you can reach the internet, verify that the printer still works, verify that Office still works. If those things all work, there's a pretty good chance you fixed what was wrong. Have the user do that and make sure the user can do everything they expect to be able to do. That will keep the user happy, because before you leave, you need to make sure that the user is happy with your work. After verifying, ask the following questions. What could we have done to prevent this? Maybe not adjust the refresh rate on the monitor. Maybe don't put your coffee cup on the CD-ROM tray when it comes out. Things like that. And then document. Good documentation helps you capture for the next guy that comes along. Use it to train people with. Use it to develop SOPs and maintenance plans. A lot of times if you're working at a company, particularly if it's a government contract or education contract or anything like that, you're going to have audits. They're going to want to see documentation frequently. You want to include initial symptoms, what the source of the problem was, your troubleshooting steps, and then which one actually worked. And once you write those things down, you should be good. Possible symptoms with possible symptoms of a problem with the electrical system. The computer appears dead. No lights, no LEDs on the motherboard, no LEDs on the front, none of the fans will spin up, and no drive sounds. Computers sometimes locks during boot. Error codes, and the error codes that you're getting are those that indicate power problems. You smell burnt or dead parts. Okay, if you smell a burning odor coming from the computer, that's an indication that you have a power problem. The computer powers down at unexpected times. That is generally what happens when it gets hot. The computer appears dead, but you hear a whine coming from the power supply. That means the fan is turning, but for some reason the power is not being transferred from the wall to the rest of the computer. Questions to ask. If you smell any burned parts, don't try to turn the system on. Open the case and look. You're going to be able to really probably very easily tell what's fried. At that point, you look at the PC processor and it's black and it has soot built up on it. Yeah, you're probably going to need to replace the motherboard. At that point, you need to look at, well, is it cheaper to replace parts or is it cheaper to replace the whole system? Check and see if the power cord's plugged in. I don't know how many times I've charged people $75 for a visit, walked in, jiggled the power cord, pushed it into the wall, turned the computer on, and left them a bill. So make sure that you check things like the simple things. Is the power outlet controlled by a wall switch? I've had that happen before. Particularly in homes, if they've got a wall switch that's directly above the power plug on the wall, walk over there, try the computer. If it doesn't come on, flip the wall switch, and then try it again. Check for blown circuit breakers. Check for loose cables. Are all the switches turned on? That switch on the back of the power supply, make sure that the little orange slider switch is set to 110 unless you're in Europe, or 115 unless you're in Europe. Make sure that the big switch above it is flipped over to the on position. Is it possible that the system's overheated? Put your hand over the air vent on the back of the computer and feel the air. There should be air, if not flowing out, then it should be able to at least feel temperature. If it feels hot, then you probably have a system that's overheating. And check for sources of electromagnetic interference. Is there a microwave or a hairdryer plugged into the same socket? You might want to look at things like that. If you need to look inside the case, turn it off, unplug it, press the power button to drain residual power from the capacitors, and open the case. Check all the power connections, check all the cards, check all the components. Make sure that your RAM and everything is plugged in carefully. All your PCI cards are plugged in, your drives, power to your drives, and the data cables to your drives are plugged in. If you smell burnt parts, look for a place where the wires might be shorted or frayed. Look for burnt wires, look for burnt spots on the motherboard. Look for soot. If you suspect the power supply is bad, get yourself a multimeter and check. You should be able to tell from the colors of the wires what type of, what polarity and amount of voltage is coming out of each plug. Check with a multimeter. If you're not getting that, then you might need to look at the power supply as being bad. Intermittent problems that come and go, are your worst nightmare, because they're going to come while the customer's there, and then they're going to go while you're there, and they're not going to do anything. And then when you leave, 5 minutes later, the customer's going to call you back and say, it's happening again. So intermittent problems are your nightmare. Computer stops or hangs up for no reason, and then it keeps working. Memory errors appear intermittently, but then they keep working. Data is written incorrectly to the hard drive, or files are corrupted. Sometimes, but not all the time. Keyboard stops working at odd times. Motherboard fails or is damaged. Now that's not really intermittent. That's an issue. I will tell you on motherboards what can be intermittent though. You open up the motherboard, particularly on a little older motherboard, you'll see capacitors. They're basically a blue motherboard component, a little round blue tin or aluminum can that's soldered to the motherboard. And occasionally you'll see one of those, the top is swollen, or it may even have a kind of a grainy looking film on it where the capacitor is overheated and popped. When that happens, it doesn't usually kill the computer directly. What it does is it causes the computer to work for a little while and then it shuts down. And it works for a little while and it shuts down. So if you see those symptoms, it's not a bad idea to open the case and see if any of your capacitors are popped. Also, the power supply fan is really noisy, or it stops. That's a bad sign. What to do to eliminate electrical systems as a source of intermittent problems? Do an analysis of the system, add up the amount of power that you need, add that 35% in, and then see if your power supply is providing enough power. Maybe the power supply is faulty. If you happen to have, it's never a bad idea to have extra components on hand, but if you happen to have a power supply on hand that would work in this situation, one that has enough power, go ahead and swap them out. It doesn't take any time to swap out a good power supply for a bad one. Swap them out, see if that power supply works. If it does, then you know, hey, this power supply that was originally in there is faulty. Don't operate the computer if the fan doesn't work. You don't want to overheat things and possibly burn up a processor. A short might occur if a motherboard component makes improper contact with the chassis. You want to look at your, particularly your larger PCIe cards, like a video card. Make sure that they're not jammed into the case because they weren't designed to fit in that case, and that they're rubbing up against the motherboard, or that they're not all the way seated in their slots. Make sure that the motherboard is not touching a conductive surface to the back of the case, like standoffs. Motherboards are screwed into little plastic lifts that hold it up off the back of the case. If you've got a missing standoff, that can cause a problem. Shake the case gently and listen for loose screws. If you hear things rolling or rattling around in the case, you might need to open the case and find out why. Shorts in the circuits may also be a problem. If you look at the bottom of the motherboard and you see damaged traces in the copper, you can right away consider replacing the motherboard. Symptoms of overheating: you get blue screen of death, system hangs or freezes intermittently, you can't hear a fan running, or the fan makes a whining, really loud, obnoxious whining sound. You can't feel air moving in and out of the grates on the case. If any of those things occur, you may have a heating problem. Also, open the case and look and see how much dust you have built up in there. If you have dust bunnies the size of a feather boa, you probably need to look at cleaning out the case, blowing it out, get a can of canned air, and blow the dust bunnies out of it. Go to the BIOS and in Setup, if it'll boot to the BIOS, then go to Setup and look at the temperature monitors. They'll tell you exactly what temperature is inside the case. And if you see something that's running 130 degrees, guess what? Your case is too hot. You can purchase a temperature sensor that will sound an alarm. It goes inside, it plugs into your power supply, and it will sound an alarm when the inside of the case gets too hot. Things to do: get more fans. Go into the BIOS, find the CPU screen that reports temperature. Make sure that the temperature is not being exceeded. If it is, then you need to use compressed air, a blower, or an anti-static vacuum to get rid of the dust bunnies in the case. Make sure the airflow is not constricted by big cards, big video cards and things like that. Make sure that the air is able to move freely. Make sure all the fans are running. If they're not, you need to replace fans. Install extra fans if necessary, particularly those if you've got a video card that uses a lot of power. You want to get one of those PCI fan cards that you can put next to your video card. Replace missing faceplates and expansion. These are the little narrow slot covers that go on the back. When the card's not being used in that slot, make sure the cover is there. You want to limit the amount of airflow to the places where it's supposed to come in and out, through the grills. You don't want it sliding in and out through holes in the case. Make sure that cables are not blocking the airflow. How to install a fan? It's simple. You've got 4 screws and a wire that you plug into the motherboard. So you screw the 4 screws in. The fan is now installed. You take the power cable for the fan, plug it into the motherboard. The motherboard documentation will tell you where you can plug it in at. Put the case so there's some space around it. You don't want to slam it right up next to the wall because then the air can't flow. Verify the cooler is connected properly to the processor. Make sure there's enough heat paste on there. I've seen that happen before. People didn't use enough and it basically didn't make a good connection between the cooler and the processor, and so heat wasn't being removed quickly enough. After closing the case, leave it off at least 30 minutes, then check the BIOS to see if the processor has been overclocked. This will cause the case to overheat. If you've got somebody that this is their gaming computer and it's an AMD processor especially, go into the BIOS and see if they've overclocked it. If you've gone from a 2.2 gigahertz up to a 5 gigahertz system, yes, your processor is going to explode. So at that point, then you need to suggest that they purchase a new processor. Too many peripherals installed inside the case. Try to leave empty slots between each card. Flash the BIOS to update the firmware. Replace the thermal compound if it's hardened. And then consider whether the case design allows good airflow. This is particularly the case if you got a small form factor case, those little flat clamshell cases, notoriously bad for airflow. A good arrangement for proper airflow, you've got the front vents pulling air in, the fans are pushing air out, and so the air flows through the case, and it covers basically all the components. Particularly, it's focused on the processor. On the other hand, you've got side vents. This would be one of those clamshell cases, those small form factors. The front of the case is up here, the drives are up here, everything's up here, but you're not getting nearly enough airflow coming through. You've got these cards here, and they're blocking the airflow, so the air's having to sneak around this way and sneak around this way. It's not covering the processor like it should. So this is a bad arrangement. This is not. This is a good arrangement. Use power supply that has vents in the bottom and the front for better ventilation. An intake fan on the front of the case also will help. You can add extra fans if you need to. Check the processor and case manufacturer. Make sure that everything that you've done is according to their manufacturer's specifications. And then Intel and AMD both recommend a chassis air guide as part of the case design. Basically, it's a kind of a round air duct that helps direct the fresh air from the outside. As the fan pulls it in, it kind of aims it more at the processor. Okay, so you've got a fan here. This is an exhaust fan. It's blowing hot air out the back of the case. You've got your power supply up here. These vents kick out a lot of the hot air. You've got your intake fan on the back of the power supply pulling air in. It's blowing air down through these fans. This is where the hot air is coming out, and this exhaust fan is catching it, sucking it out of the case. Same thing here. This is a chassis air guide. So you've got the grates here on the back side of the case, and this little plastic cone with a fan inside of it usually will pull air directly in and aim it directly where it needs to go. Generally that will be at the processor or at the hard drive slots, whatever the air needs to hit. This guide can be used to aim the air. Laptops are going to be no end of problems with heat. They're designed to overheat. So I'm just telling you. Laptop power sources, AC adapters, and you've got the brick, 2 cords, one coming in, one going out. Also uses lithium-ion batteries, and it has an auto switching feature. When you plug it in, it auto switches to the power AC. When you unplug it, it auto switches back. Also, the device automatically switches from 110 volts to 220 volts. If you plug this in Europe, it'll work. If you plug it in here, it'll work. You don't have that little slidey switch on the back. If power's not getting to the system or the battery indicator light is lit, verify the AC adapter is plugged in and verify it's plugged in correctly to all the pieces. Make sure that the AC adapter's plug is secured in the outlet and that the connectors on both sides of the transformer, that's the brick in the middle of your power cord, are plugged in correctly. And then check the connection at the DC jack. Also not a bad idea to have a multimeter on hand to check what's coming out of the DC jack. If the battery's not charging, then probably the problem is the battery or the motherboard. Hopefully it will be the battery. Otherwise, you're going to be better off just buying a new laptop. Symptoms that a motherboard or memory might be failing. System begins to boot and then shuts down. Error message is displayed during boot. System reports less memory. Okay, you know you've got 512 gigs of RAM, and now your computer's saying you've got 256. One of your chips has died. System becomes unstable, hangs or freezes. Intermittent Windows or hard drive errors occur. Event Viewer is your friend. You need to look at the System Event Viewer, and it will tell you when you're having Windows errors, when you're having drive read and write errors, things like that. Components on the motherboard or devices connected to it don't work. Check the simple things first. Is it plugged in properly? Are the RAM chips plugged in, seated correctly? Are the expansion slots filled correctly? Are they plugged in correctly? Follow steps to find the source of the problem. If it's an error message, Google it. Google is your friend. Run antivirus, anti-malware software. A memory module might be failing, so you can use the memory diagnostics tool if you've got Windows 10, 8, 7, or 11 for that matter. In the BIOS setup, there is a memory diagnostics tool to test the memory. In fact, there's a whole bunch of diagnostics tools you can use in that. Check for potential hardware problems using Device Manager. You need to open up the Device Manager, and if there's a little yellow exclamation point by the icon that represents whatever thing you're checking on, that means it has a problem. Either the drivers are bad or there's some kind of hardware problem. Event Viewer is your friend. It has logs for every single thing that your computer does. Download and install any updates or patches, and if the problem began after a change, then roll the change back. Uninstall the device or roll the update back. Follow these steps to find the source of the problem continued. Use the system window to find out how much RAM is installed and consider upgrading. You can never have enough RAM. I'm just going to tell you right now. If you can afford to upgrade RAM and you've got a slot available, do it. Check the BIOS to ensure that the proper settings are set and that the temperature is not over what it should be. Disable any quick boot features in the BIOS, then look for errors, because if you disable quick boot, it will do a lot more testing during the post-test, and when that happens, if there are errors, it will log them. Flash the BIOS with the latest upgrade or update to the firmware. Check with the motherboard manufacturer for diagnostic software. If you're, sometimes they'll send it to you, sometimes they won't. And then update all drivers of motherboard components that are not working. Follow these steps for laptops continued. If an onboard port or device is not working, verify the problem is not with the device. Like if your webcam is not working, don't immediately suspect the USB port, suspect the webcam. Go into the BIOS and verify the port is enabled. Check the device manager. Verify that Windows recognizes the device or the port. Update motherboard drivers. Use a loopback plug to check the port to see if it is working. Disable the port in BIOS and install an expansion card to provide the same type of port or connector. That's a kind of a last ditch thing there. Suspect the problem is a failing hard drive, not unless it has something to do with hard drive errors. Suspect the problem is caused by overheating. If this is a laptop, this is more than a suspicion. Laptops overheat. It is what it is. Verify the installed processor is supported by the motherboard, which for a laptop, that's kind of pointless because motherboards and laptops, or motherboards and processors in laptops were built together, unless you had someone build you a laptop, which would be crazy. So the processor and the motherboard are going to come with each other. They're going to be designed for each other. In Windows 10s 8 and 7, many continuous restart errors can be solved just by performing startup repair. That utility restores the Windows files needed to boot. So follow these steps. Using a setup DVD or USB drive. If necessary, change the boot priority, which this is like you installed Windows. If you'll recall, you had to go into BIOS and change the setup for boot to boot from the optical drive or USB drive first. Put in your install media and then boot, and instead of going to install, you're going to go to troubleshoot. Repair your computer and then troubleshoot. In Windows 8, you got to click advanced option, but I don't think anybody uses Windows 8 anymore. And then on the advanced option screen, you're going to go to startup repair. It's going to look like that. Repair your computer. You can start up in safe mode or safe mode with networking, which is always the one you want to use, is safe mode with networking. Enable boot logging. That should already be enabled. Enable low resolution. There's no reason to do that. If you're in safe mode, then that's kind of pointless. You can go back to the last known good configuration. This is particularly for configuration errors. Use a restore point and go back to where it was working. That's what that does. Debugging mode will just log a lot more stuff. Unless you really know what you're doing, this is a thing you probably don't. It's not going to be that helpful, but you should become familiar with it to the point where it does become helpful. Disable automatic restart. That's probably a good plan because sometimes you need to reboot from a cold boot instead of having to automatically try to reboot every time system fails. And then disable driver signature. That's never a good idea. Don't do that. There's no point. You're not going to have unsigned drivers unless you're doing something really outlandish with this computer. If you have checked Windows and BIOS settings and still not identified the problem, then finally you got to open the case. And for a laptop, that is the ultimate in annoyance because you have about 1,000 screws that you have to unscrew out of the back, a bezel that you have to try to pop loose without breaking on the front. There's just a lot of things that need to be done to get rid of that. So once you've gotten all those things done, then you can open the case, exchange the processor, exchange the motherboard, unless it's really specifically pointing to a processor or a motherboard error. At this point, before you go to all this trouble and start exchanging parts, I would look at buying a new laptop because frankly it's going to be cheaper. Motherboard laptops and processors are going to be expensive, and you can go to Best Buy and pick up a laptop for next to nothing that will do what you need it to do. So look at buying a new laptop before you start switching out parts. Okay, the chapter summary for module number 4. Devices used to keep a processor and system cool include CPU coolers, fans, heat sinks, and liquid cooling. Liquid cooling is like a car radiator. It uses liquid pumped through a system to keep it cool. Power supplies. Form factor, does it fit the case? Wattage capacity, do you have enough plus 30%? Do you have the right number and type of power connectors to power all the things in your case? Fan size, does it have a fan and does it work? Does it support dual video cards? Sometimes you're going to need a lot of power plugs for those dual video cards because I've seen video cards that required 3 separate power plugs in addition to be plugged into the PCIe slot. Decide on the wattage capacity and add 30%, and that's the power supply that you want to buy. If possible, when you're troubleshooting, you want to start by interviewing the user. Then do the simple things first and decide if the problem occurs before or after a successful boot, and was it caused by hardware or software. Troubleshooting laptops, consider the warranty, and replacing a component is a lot more expensive than replacing the device. And that's probably the best advice they're going to give you. If you're having trouble with a laptop, buying a new laptop is going to always be cheaper. Determine if the system's getting power. Listen for fan spinning, drive spinning, and look for indicator lights. Use a power supply tester. Intermittent problems that come and go are really your nightmare. They're the most difficult problems to solve because they do come and go. They'll come around while the user's there, but you're not, and then when you show up, the problem will go away. The battery and the DC jack in the laptop are considered field replaceable, and they are fairly easy to do, but you need to get the right parts, so make sure that you go back to the original manufacturer for those parts. Use a multimeter to check the output from the AC adapter. Listen for the beep codes if you're hearing them during the post test. Error messages on the screen while it's booting up during post. Error messages on a blue screen if you're getting BSOD and it gives you error messages. Copy those messages down, email them to Microsoft support. Motherboard, processor, all those pieces are field replaceable, but that's about all the field replaceable things that there are. An unstable system that freezes or hangs at odd times can be a faulty power supply, could be RAM, could be a hard drive, could be motherboard, could be a Windows error, could be overheating, could be bad capacitors, could be a bad power system in the building. I've actually had that happen before, so there are a lot of things to check. A post-diagnostic card can troubleshoot problems with the motherboard, so run the tests that are in the BIOS. And basically that's chapter 4. There's a lot here. You need to make sure that you, I'd go back and listen to this multiple times. I'm going to divide it up into sections in the comments on the what do you call it, on the page. I'm going to divide it up into sections. So make sure you go back and click on the different timestamps, and you should be able to see different parts. But do go back and go through this, because it does provide a lot of information as far as troubleshooting goes. Okay, so that's Chapter 4. When next we meet, we'll look at Chapter 5, and we'll go from there. I hope you have a good day and a good semester. Let me know if you have any questions.